Good morning, student. Today, I explain another one problem. Determine the vertical deflection at a point C of the truss loaded shown in figure. The cross-sectional area of the tension member is 1500 millimeter square, and compression member is 1000 millimeter square, equal to 2 into 10 to the power of 5 megapascals by unit load method. Okay, I'll explain that here. One difference in vertical deflection by unit load method or strain energy method. So here given that problem 60 kilonewton is acting at point C. So here total is A to B is 8 meter, and height is B to C is vertical height is 3 meter is there. So again you take method of joint using okay, calculate joint A. I'll take that. So find out the reaction here. It is load is acting at center. It is 60 kilonewton is there. Take reaction VA and VB will be 30 kilonewton and 30 kilonewton. So it is towards the point. Just I take 30 kilonewton directly here at point A, and another one member is BA. It is assumed that it is towards the point. Another inclined member AC. It is assumed that I will be arrow direction is away from the point. It is angle theta. So once you got that, then resolve that FAC cos theta away and sin theta is away. That here tan theta equal to same thing is opposite by adjacent side. You got opposite is 3, adjacent side is 4. You got 3 by 4. Same thing, sin theta is opposite by hypotenuse is hypotenuse will come by 5. 3, 4, 5. So you got 0.6. Cos theta is adjacent side is 4 and hypotenuse is 5. You got that 0.8. Once you got sin theta and cos theta values, then you calculate, apply your equilibrium equation. Summation of V equal to 0. 30 kilonewton is upward, positive, and FAC sin theta is downward. Then you got that minus. Okay, here will come that minus here. So FAC equal to 30 divided by 0.6. You got that 50 kilonewton. So here FAC assume that away from the point, it is called as tension. Summation of H equal to 0. Resolving force in horizontal direction. FAB is toward left side minus FAC cos theta toward right side. FAC value you already know, plus 50. You write 50. Then cos theta is nothing but 0.8. Multiply that. FAB you got the 40 kilonewton. Here arrow direction is assume that is towards the point. So it is called as compression. You write here compression that. So again you take joint P. Again here write reaction, you know already calculate VB reaction is 30 kilonewton towards the point. You write 30 kilonewton. FBA or AB. Already know FAB, you got that 40 kilonewton is compression, is towards the point. You write here directly, you write 40 kilonewton. So find out what is the force on the member BC. So assume the arrow direction. I'll assume the arrow direction is away from the point. Then you resolve that. You resolve member here. FABC is toward left side and outside downward direction. You got a summation of H equal to 0. 40 kilonewton is toward right side positive. FBC is toward left side. FBC cos theta toward left side minus. So FBC value come that 50 kilonewton. So it is arrow direction is away from the point, tension. So once you got that, then mention in the all the force on the members. Okay, what you calculate AB, BA, FBC and FAC values. So one after that, then apply your unit vertical load method. Vertical load at point C, member, force on the member. Okay, forces shown in the figure means you remove the 60 kilonewton. What you calculate previous you write 60 kilonewton you apply, you know. Here the same thing, unit load method is nothing but remove the 60 kilonewton, then apply 1 kilonewton. Again find out the joint free body diagram of joint A and free body diagram of joint B. Then your reaction is total load is 1 kilonewton. Your reaction is 0.5. Your reaction is 0.5. Then find out what is the force on the member AB and AC. Same thing. Then you take free body diagram of joint B. Then find out the force on the member BA and BC. BA already know that. Only calculate the BC on the force on the member. So I write directly here 0.667 for AB and AC and 0.3833. Here BC also 0.833. So this is a value will come that. So after that, then go by table. What is the member length, area, P values, what are force given load values, forces, and this is small k is nothing but unit load of forces values, and PKL by A. So AB, you write members AB, BC and CA members. Length is no, A to B is 8000 millimeter, 8 meter, you write in millimeters, and AC is inclined 5 millimeter, 5000 millimeter, and BC also 5000 millimeter. Area is no compression. Okay, here you know that compression members AB, you know, compression member is 1000 and tension member is 1500 is there. This is for it is for tension, that sorry, it is a compression, it is towards the point. Okay, then you write 1000 millimeters, so tension is 1500. So value P value, you know, it is towards the point, tension is there, you write minus 40, and this is for tension is there. Okay, you write plus 50. Here this is compression. So K equal to, this is K is nothing but what given apply load, unit load 1 kilonewton, then what is the force on the members. Here also same thing, you got the compression 0.667, you write minus 0.667. Here both are tension is there, 0.833, 0.833. So what is that, you multiply with PKL by A. P, you know, 40 minus 40, K is K value is minus 0.667, and L is 8000 divided by 1000. So you got that add these all three values, summation of PKL by, you got 491.1. then vertical deflection equal to 491.1 divided by E. E is no 200 MPa, then you got the 2.45 millimeter vertical deflections. The same problem, suppose asking in here both horizontal and vertical deflection is there, only one another two column is insert. Here PK is there, PKL by you got vertical. Same thing, you write PK dash L by A. Okay, you apply 1 kilonewton in the horizontal direction, then again find out what is the force on the member. That is called as horizontal deflection. That. So suppose strain energy method. Okay, your strain energy method is there. Only thing that you not apply 1 kilonewton in the vertical, you calculate directly. K is not there, so only that formula member length area P and P square L by A. Okay, it is a P will be square, P square, here a square of these values, and L, you know, same millimeter, and area is also millimeter square. So totally summation of P square L by A is 29466.66. you got the summation of P square L by A. What is the formula? Delta V is equal to 1 divided by W into E, summation of P square L by A. So substituting values, 1 by W is nothing but 60 kilonewton, and E, no, 200 MPa, and summation of P square L by A is given these values, substituting. Then you got the vertical deflection also same 2.45 millimeter. This is strain energy method, and unit load separate in only vertical deflection calculate. Horizontal deflection, suppose strain energy method and unit load method both are same. Thank you.